Hi. Today we want to talk about section 3 of chapter 5 in Savage book. That's called Using Procedural Abstraction. So we talked about this already a little bit here and there. We talked about it in chapter 4. We just kind of refreshed this idea that we are treating the functions like a black box. So the people who use the functions, they don't really need to know the detail of it. So we're going to be just using it. So we're going to be thinking about that. So they will see the declaration and comments. So what they see from my code, eventually in the future, we're going to put the top portion of our program as a header file. So the declaration and global constants are going to be separate from our code. So nobody's going to see my CPP file, but they are available to the header file to see the declaration. So if somebody look at my declaration of one of the functions that I have, they should know exactly what that function is doing. So the comments are very, very important, and they don't need or they shouldn't be looking at my code to make sense. And that's why the comments on the declaration is so important. We can think about it as the car. We really don't want or really we don't want to get into how the engine or transmission work, how all the parts and all those things are working. All we know is how to use them. So if I sit in the car and push a start, my engine start working. I don't know how is it working. I don't know what is going to be working, but all I know is my interface to the engine is the start, and of course, turn it off, turn it on and turn it off. Same thing goes with the transmission. So if I am looking at the transmission, it's a very, very complicated machine. And if I really want to learn it, it's going to take me quite a few months to know all the little parts in the transmission. But I don't need to know all those details to use the transmission. So I can put it in a drive, goes forward, put it on R, goes backward, put it on N, it's going to be idling. So that's what we're talking about, the functions as a black box. So people can use our function without knowing the details of it. And another thing that came up in chapter 4 was that we can take this engine and put another engine in it. And from the driver point of view, it wouldn't make any difference. So I blow up the engine, they put another engine on it, or the car has an electric engine or it has a hybrid engine. Doesn't really matter how it is implemented as far as I push the start and it's going to go, and then I can turn it off and it's going to stop. So that's what we're talking about, the black box. That's the way we're going to treat our functions. People can use our functions. So we have to have enough comment that if somebody looks at my comment, they understand what the function is doing. So we can have a function call inside the function. I talked about this in the last meeting, that we can call another function into another function. We don't want to do this too much. We don't want to overdo it. So a technique called spaghetti programming is I go to a function, and this function is going to take me to another function, and that function is going to take me to another function, and go on and on and on, and I basically got lost all over the place. So it's okay to call a function inside a function, but we have to stay on the task. What is my function is doing? And I'm going to stay in the task for that function. So if my function is going to calculate something, I'm not going to call the input function into my calculating function. It has to be independent enough so I can take that function, put it somewhere else that's going to work. So whenever we call a function inside another function, that function is going to have dependency. So that means if I move this function somewhere, the other one has to move with it too. You will learn about the namespace and all those things and how we can package these things and move them, but not right now at this time. But definitely we cannot put the code inside of the other one. It has to be separated. So we have this function called order, we're going to check to see if N1 is greater than N2, then we're going to swap them. So this swap function only going to happen if N1 is greater than N2. So that means we want to do it in the descending order. We can do it this way. If we want to do it ascending order, is the other way around. So this is example display 5.8 in your book that is talking about this, that the order is right here. That's going to be called, and it's going to have enough comment for us to be able to understand. So remember, any of these functions, if I look at the comment, I shouldn't need to go to the coding to understand the function. So whenever you're looking at somebody else's code, take a look at these comments, see if they make sense. So your book is talking about precondition, postcondition, and I've been talking about IPO, input, processing, output. I think it's a good idea to learn both of them, and then you can practice on one or the other one, but it's good to know both of them. So the idea of the precondition is, what do we need to have before we start this function, before we call this function? What do we need to have? So in our engine situation, I am going to need a battery to be able to start the car. So if my battery is dead, I cannot start my car. So if I have a function that's my engine, for that, I need to have a battery charge enough to turn the engine to be on. And I just needed to turn it on. So I need that. And of course, that's the condition, the precondition. And the postcondition says, okay, what's going to happen after we call this? So what can be true? What is if the precondition is correct? If my battery is charging my car and I push the start, the engine gonna run. And then we also talk about the postcondition, what is going to return. So what value is going to return for us. So that is called by reference. Parameter is going to be described. If it's just a return value, it's going to be described. So that's what we're going to be describing. So going from here to my thinking, input, processing, output, that we were talking and applying to the main program, is the question is, what is this function doing? So I'm going to put the description of the function first. What is the task is doing? And we have to be careful. We have to be careful that the function is only going to do one task and one task only. So if I'm describing and I say this function is going to do this and this and this and that, that is not a good function. We have to separate those things. We have to stay with the task. And when we're defining the task, when we describe the task, of course, this is part of your design. Then we can use that description to create the name of my function. The next one is, what is it coming into my function? So everything I need to come into my function has to come through the parameters. We are not going to have any global variables. That's going to make everything messy. So everything I need in my function has to come into it through the parameters. The next one is out. What kind of a data is going out? So if I have only one data going out, I can have a return value or have it as a pass by reference. And if I have more than one return value, I don't have a choice of except putting it in as a parameters. So we're going to put it in the parameter as a call by reference. Now, if we go back and look at the swap value function, this is the way that your book is describing the precondition. Variable 1, variable 2 have to be given values, or in this case, n1 and 2. And then postcondition, the values of the variable 1 and variable 2 have been interchanged. So we need these two values to come in, and then we're going to change them. Now, taking this one and use the IPO on it, the processing or the task or description for this function is this function will swap variable 1, which is n1, with variable 2, which is n2. What's coming into my function is variable 1 or n1 and variable 2 with or n2. And what's going out is my variable 1 and variable 2. So in this case, you can see that I have two things going into my function and two things coming out of it. So every time I have more than one thing going out of it, I have to do it as call by reference. So the parameters that's coming out of my function have to be called by reference. We can have a return value over here too. So I could potentially return one of them here, but because I'm just receiving those two, and it's easier to just return it. So if you remember, we worked on the Celsius function. That Celsius function was taking a Fahrenheit, change it to Celsius. So in this case, we are, for a precondition, your book is talking about Fahrenheit is a temperature expressed in the degrees Fahrenheit, and the postcondition is going to return equivalent temperature expressed in degrees Celsius. So if I want to apply IPO to this one, I'm going to have converts Fahrenheit to degrees in Celsius. So I'm going to use this to come up with a name. So I wouldn't be calling it Celsius. I would say Celsius to Fahrenheit, or I mean Fahrenheit to Celsius, or convert, or some kind of a more descriptive than Celsius. What's coming into my function is a Fahrenheit degree. Remember, the reason I put this one here is for you to know that the declaration doesn't have to have a variable. It just can be like that. I mean, I always put it in there, but I just want to tell you that you don't need to have a variable when you do your declaration. And then what's coming out is going to be the Celsius that's coming out. So I'm showing you both of them. You choose one of them. You don't have to use both. Either you're going to use precondition, postcondition, or you're doing the IPO and just. So why do we do this? The idea of these things is what? Before we start writing code, we're going to sit down and think about what is this function doing, what is going on with this function. A lot of us, we want to jump into the coding and start writing code, and then we start changing stuff, it doesn't work, and we're putting a lot of things in there. So if we take our time and step back and think about what each function is supposed to do, and we think about the function should do only one task, then we can organize it differently. And remember, if I need a variable in one function that comes from another function, I have to pass it to the parameter or call the other function inside of this function. So we always start with our design. We're going to end up with function declaration with comments, and then we're going to take those, copy to IDE, and copy the section about the pseudocode and put it in the IDE and start writing code. So basically, when I'm writing code, I'm just transferring my pseudocode to C++. And I can take the same thing and put it in different language. So when I'm doing the coding, my main focus is how to structure my coding, how to compile it, how to run it. Those are the area. My thinking has happened before I start writing code. And of course, we're going to minimize the design error. And so this is the part that I'm really concerned, that if you jump into coding without thinking about it in your design time, you're gonna have some code that you have to go back and delete it. You might have some code that's not doing the task in hand because you say you're thinking about something and then you say, oh, what about this? And then you put the code in there. It's just gonna put too much code in an area that's not even related to that. So we're going to be looking at a couple of examples here from your book, and these are coming from your book. So in this case, we have a supermarket that wants to have a markup of a 5% if the item is going to be sold by 1 week. And if it's going to take more than 1 week, we're going to have a markup of 10%. So it does explain this a little more. So the first 7 days is going to be always 5%. And then if it goes to 8 days, then it's going to be 10%. So we're going to be talking about what's coming into program, what's going out of the program, my input and output. So remember, moving forward, everything is going to be function call, function call, function call. So in this case, we are looking at the functions. The first one is going to be my input, my I from IPO. And then I have to compute the retail price. That's going to be my processing. And my output, which is displaying the result, that's my IPO. So we're going to take these functions and we're going to be looking at it. This is our design area. We're going to think about the design area. And then we can think about call by value versus call by reference. So if something coming out of my function through the parameter, that's going to be called by reference. If it goes in and doesn't come out, it's going to be called by value. Again, one function should do one task and one task only. So we start with our get input. Our get input is going to have cost and turnover. We're going to ask the user for these two, and then we're going to return. So rule of thumb, every time we have an input function, all the variables have to come out. So if they're coming out, it has to be called by reference. So everything that I have coming out of my function has to be called by reference. So rule of thumb, get input, input function, user input, generally have all parameters called by reference. The next one would be my calculation. So I'm going to put the description of this that we are going to calculate the price based on the cost and turnaround. So it puts the price over here. I would put a little more than that to be more descriptive. So it's calculate price or something like that. So in here, I have two parameters going in and one coming out. So when I have, and they are not the same thing. So the cost goes into this function, but it doesn't come out. Turnaround is going to this function, is not coming out. So these two are going to be called by value. Now I have one thing that's coming out, that would be the price. That can come in as a return value, or if I decide to put it as a parameter, it's going to be a parameter with called by reference. So I could put the price over here and add another parameter here, and I would say double and % price right here. So if I have one return, I can put it here, or I can put it as a parameter. I like return value functions generally because I can put them into an expression. So even if I have 2, 3 things coming out of my function, maybe I put one of them as a return here. That way I can just put my function in an expression. So it's just a different style, nothing important about that. And of course, giving the output, I have three things going in there and it's not coming out. So general rule of thumb for output is you don't have anything as called by reference. So your output, your variables goes in, we're going to display it, and we're going to be done with it. And it's generally a void function. Okay. So this is something that I want to emphasize again, that main function should be only function call. And you can see this here, that we have get input, doing our processing, getting the price, and give the output. So my whole main is going to be function call, and function call. And if I need my retail price here, if I need a retail price from here, I'm going to get it from the calculation and I'm going to pass it as a parameter. So we're going to be writing the pseudocode. Again, remember pseudocode, it's going to be a mixture of code and English. I try to stick with the English part of it because I don't want to be thinking about the code that much. So we're going to be writing the pseudocode for each function that we are talking about. So in this case, if the turnover is less than or equal to 7, the cost is going to be cost plus 5% of the cost. That's going to be my price. If it's otherwise, that means it's higher than 7, then it's going to be 10%. We're going to create global constant variables. The reason we do that is we don't want to have the hard-coded numbers in our program. And remember, we're going to give those global constant to the user, to the other developers. So in case somebody somewhere decided that they want to change this 5% to 6%, or this 10% to 9%, or this 7 to 8, they don't have to come and call me. So they don't need to call me, because if I am writing a program and I hard code all these numbers, and if the user decided that, you know what, my low markup is not going to be 5% anymore, I want to reduce it to 4%. So if that happens and I don't have it as a constant global variable, then they're going to call the company, my company, somebody's going to get hold of my supervisor or project manager, and my project manager is going to get hold of me. I have to go into the program, look for a number called 05, and I have to figure out if that 05 is actually my low markup and it's not for something else somewhere else, and then change that one. And now I have to compile my program. And every time I compile my program, I have to compile everything related to this program. And sometimes it's going to take a long time to do that. While if I put it like this and I give it to in as a header file, like a config file for some other places, even the user can go in there and change this 5 to 6 or 4 or whatever they want, and we don't have to compile it anymore. Okay, so that's for that one. And now we figured out so we have the pseudocode and we have the functions. Then we can go look at the program. This is how much comment you want to put. I know I am a programmer. I'm a lazy programmer. I don't want to type. I understand that, but we have to do it. Not necessarily we can do everything that we want all the time. Sometimes we have to do things because we have to do it. So that's the declaration. That's the definition for those. And because we're just using this one here, we're going to be using the namespace in the function. And of course, sample run. So this is something that we're going to do as activity 5.3 and be ready to talk about it in class. Okay, that's going to conclude this one.